everyone, this is Chinnaiah Kalpana here. In this video, we're going to solve a differential equation from higher order linear differential equations with variable coefficients. So let's get going. Problem solve x cube d cube plus 3x square d square plus xd plus 8 into y equals to 65 cos of log x. We are given a differential equation with variable coefficients. Now we are going to reduce this differential equation to a differential equation with constant coefficients by making substitution. Okay. And also we are given a Cauchy's equation. Given Cauchy's equation, x cube d cube plus 3x square d square plus xd plus 8 into y equals to 65 cos of log x. Let's now make the substitution. Put x equals to e cos z, then log x to the base equals to z for x greater than 0. Let theta equals to d by dz. Here theta is a differential operator with independent variable z. Then xd is theta. X square d square is theta of theta minus 1, which is equals to theta into theta, theta square minus theta, right? And x cube d cube is theta of theta minus 1 into theta minus 2. We know that theta of theta minus 1 is theta square minus theta. So let's write theta into theta minus 1, theta square minus theta into theta minus 2, which is equals to theta square into theta, theta cube minus theta square into 2 is 2 theta square minus theta into theta, theta square minus into minus plus theta into 2, 2 theta is equals to theta cube minus 2 theta square. Okay, minus 2 theta square minus 2 theta square is minus 3 theta square plus 2 theta. Okay, now the above equation becomes, replace x cube d cube by theta of theta minus 1 into theta minus 2. We'll get theta of theta minus 1 into theta minus 2 plus 3 into, replace x square d square by theta of theta minus 1 plus, replace xd by theta plus 8 into y equal to 65 cos of, replace log x by z. We'll get 65z, right? Then theta into theta minus 1 into theta minus 2 is theta cube minus 3 theta square plus 2 theta. Plus 3 into theta of theta minus 1 is theta square minus theta plus theta plus 8 into y equal to 65 cos z, right? Then this becomes theta cube minus 3 theta square plus 2 theta plus 3 theta square plus into minus minus 3 theta plus 8 into y equal to 65 cos z. So here minus 3 theta square plus 3 theta square gets cancelled. Okay. 2 theta plus 3 theta is theta. So 3 theta minus 3 theta gets cancelled. Okay. We'll see that in the next step. This equation becomes theta cube plus 2 theta plus theta is 3 theta minus 3 theta plus 8 into y equal to 65 cos z plus 3 theta minus 3 theta gets cancelled and we'll get theta cube plus 8 into y equal to 65 cos z. So we have reduced the given differential equation with variable coefficients to a differential equation with constant coefficient, right? And also this is in operator form, f of theta into y equals to some function of z. where f of theta equal to theta cube plus 8. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. First we will find yc using auxiliary equation and later we'll go for yp. Right? The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of theta, theta's cube plus 8, right? Let's replace differential operator by m, so that we'll get f of m equals to m cube plus 8. Now the auxiliary equation becomes m cube plus 8 equals to 0. Let's now find roots using synthetic division method. Just consider polynomial m cube plus 8. Okay. Let's place the roots, coefficients of m's. Coefficient of m cube is 1 and coefficient of m power 0 is 8. Now let's see which m satisfies this polynomial for m equals to 1, minus 1, 2, minus 2 and so on. Okay. Here we are having m cube plus 8, right? We know that 2 cube is 8, but 2 cube is plus 8. We need minus 8. So, by replacing m by minus 2, we'll get minus 8, right? If we put m equals to minus 2, we'll get minus 2 whole cube plus 8, which is equals to minus 8, because minus into minus is plus. Sorry. Minus into minus plus, plus into minus minus. So you'll get minus 2 cube is 8 plus 8. Minus 8 plus 8 is again 0. So for m equals to minus 2, we get m cube plus 8 equals to 0, right? So m equals to minus 2 satisfies this polynomial. Let's put m equals to minus 2. We'll get 1 plus 0, 1. Minus 2 into 1, minus 2. 0 minus 2 is minus 2. Minus 2 into minus 2 is 4. 0 plus 4 is 4. Minus 2 into 4 is minus 8. Plus 8 minus 8 is 0. Again, this gives a polynomial m square minus 2m plus 4. So we can write m cube plus 8 as, see, from m equals to minus 2, we'll get m plus 2 equal to 0, right? Just take this or bring this minus 2 to LHS, we'll get m plus 2 equals to 0. Now we can write m cube plus 8 as product of m plus 2 into m square minus 2m plus 4. Right? Now coming to this equation, we'll get m plus 2 into m square minus 2m plus 4 equal to 0. Now equate each factor to 0. We'll get m plus 2 equal to 0 and m square minus 2m plus 4 equal to 0. From m plus 2 equals to 0, we'll get m equals to minus 2. And from this equation, we'll find roots using m equals to minus b plus or minus square root of b square minus 4ac by 2a, quadratic formula. Right? Just compare this equation with quadratic equation in m. Then we'll get a equals to 1, b equals to minus 2 and c equals to 4. This equals to, just place the values in this formula, we'll get minus of minus 2 plus or minus square root of minus 2 whole square minus 4 into 1 into 4 by 2 into 1, right, which is equals to Minus of minus 2 is 2 plus or minus square root of minus 2 whole square is 4 minus 4 fours are 16 by 2, right? This equals to 2 plus or minus square root of 4 minus 16 is minus 12 by 2. Now we can write this as 2 plus or minus, write minus 12 as minus 1 into 12 by 2. This equals to 2 plus or minus square root of minus 1 into, we can write 12 as 4 into 3. Right, this equals to 2 plus or minus. Now write square root of minus 1 into 4 into 3 as square root of minus 1 into square root of 4 into square root of 3 by 2. We know that square root of minus 1 is I and square root of 4 is 2. So we can write it as 2 plus or minus I into 2 into root 3 by 2. Now take 2 common from the terms of numerator. We'll get 2 times 1 plus or minus I root 3 by 2. Here 2 gets cancelled and we'll get 1 plus or minus I root 3. A pair of complex conjugate roots from the second factor and from the first factor will get a real and distinct root minus 2, right? We'll get m equals to minus 2 and 1 plus or minus I root 3. Fine. We know that when we have one root, then yc will be c1, one constant into e power the real root into z, and we know that a plus ib is a complex number and its conjugate is a minus ib. Likewise, if a minus ib is a complex number, its conjugate is a plus ib, right? So we can call a plus or minus ib as complex conjugate number or a pair of complex conjugate roots, right? When m equals to a plus or minus ib, yc looks like e power a into z into, we need two constants. Already we have used c1, so let's take c2, c3 as another two constants. So we'll use c2 and c3 here. c2 cos bz plus c3 sin bz. Fine. Now let's write a complementary function based on these formulas. Yc equal to, firstly we are going to write for minus 2, right? Here minus 2 is a distinct, real and distinct root. And 1 plus or minus I root 3 is a pair of complex conjugate root. Okay, fine. Now let's write yc. First we will write for minus 2. We'll get c1 e power real root into z plus, now coming to complex conjugate roots. For a equals to, just compare 1 plus or minus I root 3 with a plus or minus ib. For a equals to 1 and b equals to root 3, we'll get e power, for a equals to 1 we'll get 1 into z into c2 cos b. For b equals to root 3 we'll get root 3z plus c3 sin root 3z, which is equals to c1 e power minus 2z plus e power z into c2 cos root 3z plus c3 sin root 3z, right? Now we are having yc in terms of z, but we need to write in terms of x. So what we'll do is we'll just replace e power z by x and z by log x. Okay, so before replacing e power z by x, we'll write e power minus 2z as c1 e power z whole power minus 2. Okay, and remaining we'll just write as it is, c2 cos of root 3z plus C3 sine of root 3z. Now let's replace. E power z by x will get x power minus 2 plus x into C2 cos of, replace z by log x will get root 3 log x plus C3 sine of root 3 log x. Right? These are required YC. See, we are having x power minus 2, right? We know that x power minus n equals to 1 by x power n. We can write YC as C1 into 1 by x square plus x times C2 cos of root 3 log x plus C3 sine of root 3 log x. We can write C1 into 1 by x square as C1 by x square. Okay? Plus x times C2 cos of root 3 log x plus C3 sine of root 3 log x. Right? We can use any of these two, YC, or we can write two solutions in JS, I mean general solution, using the first YC and the last YC. Okay, we'll see in both the cases. Now let's go for YP, particular integral. We'll find YP using 1 by f of theta into q of z, which is equals to 1 by f of theta. We have theta is q plus 8 and q of z is 65 cos z. We can write it as constant into 1 by theta q plus 8 into cos z. So this is of 1 by f of theta into cos az form, right? We have f of theta, theta q plus 8. Now compare cos z with cos az, then for equals to 1, we'll find theta square, which is given by minus of a square, which is equals to minus of 1 square equals to minus 1. Okay, and by replacing theta square in the denominator must be non-zero. Okay, if you get denominator 0 by replacing theta square by minus 1, if you get denominator 0 by replacing theta square by minus 1, we'll get something like this, 1 by 0 into cos z. Since 1 by 0 is undefined, so total term becomes undefined, right? So always remember that the denominator must be non-zero. Now coming to the problem, we can write theta cube as, we are having theta cube plus 8, right, above theta. We can write theta cube as theta square into theta. Now just replace theta square by minus 1, we'll get minus 1 into theta plus 8, which is equals to minus theta plus 8, which is non-zero, right? So we'll split theta cube as theta square into theta, and later we'll replace theta square by minus 1 because we are getting non-zero by replacing theta square by minus 1 in the denominator. This equals to 65 into 1 by split theta cube as theta square into theta plus 8 into cos z. Now replace theta square by minus 1 in the denominator. We'll get 65 into 1 by, replace theta square by minus 1, we'll get minus 1 into theta plus 8 into cos z, which is equals to 65 into 1 by minus theta plus 8 into cos z. Fine. Now we can write this as 65 into 1 by 8 minus theta into cos z is equals to 65 into 1 by 8 minus theta into, see in the denominator we having minus, right? Just replace it with plus, then we'll get 8 plus theta. Now multiply and divide 8 plus theta to the fraction, to this fraction. Is equals to 65 into 1 into 8 plus theta is 8 plus theta by 8 minus theta into 8 plus theta is 8 plus theta into 8 minus theta into cos it. So the denominator is of a plus b into a minus b form. So let's write it as a square minus b square. This is equals to 65 into 8 plus theta by 8 square minus theta square into cos it. Again theta square appears in the denominator. Let's see what happens. If we replace theta square by minus 1 in the denominator, we'll get 8 square minus theta square equals to 8 square is 64 minus theta square is replaced by minus 1, we'll get 64 minus into minus plus 1, which is 65 non-zero. Since the denominator becomes positive, non-zero by replacing theta square by minus 1 in the denominator. So we'll just dare to replace theta square by minus 1 in the denominator. Replace theta square by minus 1. YP becomes 65 into 8 plus theta by 8 square. 8 square is 64 minus of replace theta square by minus 1 into cos z is equals to 65 into 8 plus theta by 64 minus into minus plus 1 into cos z, which is equals to 65 into 8 plus theta by 64 plus 1 is 65 into cos z. Here 65 gets cancelled and this is equals to 8 plus theta into cos z. This becomes 8 cos z plus theta cos z. We know that theta is a differential operator. We can replace theta by dz. This is equals to 8 cos z plus replace theta by dz. Now we need to find derivative of cos z with respect to z. This is equals to 8 cos z plus derivative of cos z with respect to z is minus sin z, which is equals to 8 cos z plus into minus minus sin z. See, we are having yp in terms of z, but we need to write in terms of x. So we'll replace z by log x. Okay, this becomes 8 cos of log x minus sine of log x. So this is our required yp. We got yp and yc. Let's now write the general solution. The general solution is given by y equal to yc plus yp. Then y equal to yc, we have two yc's, right? First we will write for the first one, c1 x power minus 2 plus x times c2 cos of root 3 log x plus c3 sine of root 3 log x plus yp 8 cos of log x minus sine of log x. Okay, or y equal to c1 by x square plus x times c2 cos of root 3 log x plus c3 sine of root 3 log x plus yp. Okay, so this completes the problem.